Everything around us, metals, plastic, glass, and even the phone in your hand, is made of atoms. Inside every atom are tiny particles called electrons. These electrons follow special rules described by quantum physics. These quantum rules control how electrons move and where they can exist. Understanding these rules helps us explain how electricity flows in materials. In an atom, electrons cannot move anywhere they want. They can only stay in specific energy levels. These are called quantized energy levels. An electron can jump from one level to another only if it gains or loses energy. When atoms are very far from each other, their electrons behave independently. Each atom has its own separate energy levels. This is how electrons behave in isolated atoms. But in solids, billions and billions of atoms are packed very close together. Because they are so close, their electrons start interacting with each other. These interactions cause the original energy levels to split into many very closely spaced energy levels. When a huge number of atoms come together, these closely spaced energy levels form continuous regions called energy bands. So instead of a few separate levels, electrons can occupy many energy states within these bands. The lower energy band filled with electrons is called the valence band. Electrons in the valence band are usually bound to atoms and cannot move freely through the material. Above the valence band is another band called the conduction band. When electrons reach this band, they are free to move through the material. This movement of electrons creates electric current. Between the valence band and conduction band there is a region where electrons cannot exist. This region is called the band gap or energy gap. The size of this band gap determines whether a material conducts electricity or not. In metals, the valence band and conduction band overlap. Because of this overlap, electrons can easily move to higher energy states. This is why metals conduct electricity very well. In insulators, the band gap between the valence band and conduction band is very large. Electrons cannot easily jump across this large gap. Because of this, insulators do not allow electric current to flow. Semiconductors have a small band gap. With a little energy, electrons can jump from the valence band to the conduction band. This makes semiconductors very useful in electronic devices. Band theory is the foundation of modern electronics. It explains how transistors, solar cells, LEDs, and computer chips work. Without understanding band theory, modern technology would not exist.